Question is, in precipitation of water softening, lime is used to remove calcium hardness by this reaction. Lime we are using for softening of the water. So the reaction was given and its molecular weights are given. We have to find out what dose of lime with 78% of purity of CaO is required to combine with 70 milligrams per liter of calcium. 70 milligrams per liter of calcium was used. From the above equation, we know that 100 milligrams per liter of CaCO3 requires 56 milligrams per liter of pure CaO. Therefore, 70 milligrams per liter of CaO3 requires how much of pure CaO? That is equal to 56 by 100 into 70. That implies 39.2 milligrams per liter is pure. So, impure lime, because of 78% of purity of CaO, impure lime required is equal to 39.2 by 0.78, that is equal to 50.3 milligrams per liter is required. 50.3 milligrams per liter is option B, and option B is correct. Question is, if the average center to center spacing of the vehicle is 20 meters, center to center spacing we can say S is 20 meters, then the basic capacity of the traffic lane at a speed of 50 kmph. We have to find out the basic capacity of the traffic lane. Let we say the basic capacity E we have to find out, and the speed of the vehicle was given as 50 kmph. We know that basic capacity E is equal to 1000 into V by S. This E is in terms of vehicles per day. Vehicles per, not day, per hour. 1000. This V is in kmph. This is in meters. So 50 kmph by 20 meters is equal to 2500 vehicles per hour. This is vehicles per hour. Option was given as vehicles per hour. So 2500 vehicles per hour, it was option C is correct. Is the DO deficients at upstream and downstream stations are. The upstream and downstream stations DO deficients were given. We can say D1 as upstream DO deficients and D2 as downstream milligrams per liter. So the time of travel in this stream reach is 0.67 days. So delta T is given as 0.67 days. The mean water temperature is 26.5 degrees centigrade. What is the reaction rate constant value for 20 degrees centigrade? We have to find reaction rate constant at 20 degrees centigrade. So reaction rate constant at 26.5 degrees centigrade is equal to D2 by D1 delta T, that is equal to 2.77 by 3.55 divided by 0.67, that is equal to 0.37 per day. We know there is a relationship for the reaction rate constant for different temperatures. So K at 26.56 is equal to K at 20 1.02 whole power temperature T minus 20, that is here T is 26.56. By substituting these values we will get K at 20 degrees centigrade as 0.33 per day. So option A is correct. In this question, we have to match the list 1 with the list 2. If we don't know the answer also, we can eliminate the two options in the options given below. How? If you see R, it is a function of A and B. So if you see in the list 2, the function of A and B is going to be option 2. So we can eliminate the C and D. Only two options are going to contain are matched with list 2. So if you see the option list 2 option 1, it is a triangular varying load with W naught. So maximum bending moment at the two ends is going to be WL square by 21 minus WL square by 20. So P and P is matched with 1, P is matched with 1 and R is matched with 2. Only option A is going to suit the matching the list 1 with the list 2. So option A is correct. We have to find out the value of H. The question is, the three hinged arch shown in the figure will have a value of H. We have to find out H. So in this arch, first we will find out the vertical reaction V. We will find out V. How to find out V? If we take the moments about this axis, let's say X, let we take the moments about X axis, V into 16 is equal to 80 into 12. This is 8. This 12 is coming from 8 plus 4. 8 and 4. So that implies V is equal to 60 kilonewtons. But we have to find out H. Let me take the moments about this center P. Moment about P. H into 4 plus 80 into 4 is equal to 60 into 8. This is anti-clockwise, this is clockwise. These are anti-clockwise. So from this equation we will get H is equal to 40 kilonewtons. 40 kilonewtons is option C. Option C is correct. Is a flat steel plate is of trapezoidal form of uniform thickness T is equal to 10 mm and it tapers uniformly from a width of 50 to 100. So if we show the figure, it is tapering from a width of 54 to 50 to 100 over a length of 400 mm. Then the elongation of the plate under an axial force of the axial force is given as 50 kilonewtons. At each end will be, we have to find out the elongation at each end. Elongation delta we can represent. We have to find out the delta. We know for a taper section the elongation delta is equal to FL by the width B2 minus B1 into thickness into modulus of elasticity log base E B2 by B1, where B2 and B1 and B2 we can represent. So by substituting these values, we can get the value as 0.1352 mm. All the dimensions should be in a single units. So 0.1352 mm, option B is correct.